we are going to start the additional formula. That is, on the basis of this, we are going to state and prove Theorem 1. For alpha comma beta belong to R, we have to derive cos of alpha minus beta is equal to cos alpha into cos beta minus plus sin alpha into sin beta. And the second one is cos of alpha plus beta, that is cos alpha into cos beta minus sin alpha into sin beta. So we are going to derive this result, that is the theorem first, that is the addition formula. So the proof of this theorem is alpha beta may be of different kinds. So the first case is we take a let alpha and beta belongs to 0 to 2 pi interval. That is, we can take alpha and beta equal to 0 and less than 2 pi. So in this case, we have three possibilities. The three possibilities are there. What is these? First one is alpha may be greater than beta. Second one is both are equal. And third one is alpha is less than beta. So these are the three cases. So first of all, we are going to draw a circle, that is a unit circle. This is x-axis, this is y-axis. We draw a unit circle, that is the origin. So let A is here 1, 0 with coordinate. Let P of alpha be any point with angle alpha. Then let me draw P of beta with the positive axis, that is Q of beta. This is this angle. Then what is alpha minus beta? Suppose if it is 120 and this is 40, then alpha minus beta is 80. So we are going to draw, that is alpha minus beta, that is R. So this is R of alpha minus beta. This is P of alpha, that is our coordinate cos alpha, sin alpha, cos of alpha minus beta, sin of alpha minus beta, cos of beta, sin of beta. These are the coordinates of these P, Q and R. So we are going to discuss the first case, that is the case 1, that is alpha greater than beta. So what about this case? This case is, suppose the trigonometric point, as we discussed, on the unit circle corresponding to alpha and beta and alpha minus beta are P, Q, R respectively, as discussed in earlier diagram. So by definition of circular coordinates, we have P of alpha is equal to cos alpha comma sin alpha, that is x coordinate is cos alpha and y coordinate is sin alpha. and Q of beta will be cos beta sin beta, and R of alpha minus beta is equal to cos of alpha minus beta sin of alpha minus beta. So also, as we have coordinate of A are 1, 0, and as we know that length of arc AP is alpha, length of arc AQ is beta, and length of arc AR is alpha minus beta. And as beta is less than alpha, Q belongs to arc AP, that is lying on the arc AP, as beta is less than alpha. Therefore, length of arc PQ will be length of arc AP minus length of arc AQ. Just as this is the A, this is P. So length of arc AP, Q is lying here. So what is length of arc PQ? That is AP minus AQ give this length arc PQ. So it becomes length of arc AP is alpha and that is AQ is beta. So it is equal to length of arc AR, that is alpha minus beta. As arcs are congruent, that is chord corresponding to congruent circles with congruent arcs of the same circle are congruent. That is, if two arcs are congruent, then chord made by these 2 points, that is PQ chord and AR chord, will also be equal. That is congruent. If they are congruent, that means they are equal. Therefore, PQ length is equal to AR. That is, if we are taking the square of both, it is PQ square is equal to AR square. Now we have to find what is PQ and what is AR. To give it name as number 1. That is star, not number 1. That will be confused because we are going to prove the first case. So we will take its name as star. Now we have to find PQ square. PQ square means coordinate of, we have to know about the coordinate of P, that is known, coordinate of Q, that is also known. Then we use a distance formula, that is x1 minus x2 whole square plus y1 minus y2 whole square, and then taking the square root of these two squares. So we have to take PQ square. PQ square means under root is not there. So we take x minus x2 whole square plus y1 minus y2 whole square. Now we will use the formula of square, that is a minus b whole square, that is a square plus b square minus 2ab plus a square plus b square minus 2ab. So here you can see that we have cos square alpha plus sin square alpha, that is 1, cos square beta plus sin square beta, that is 1, minus 2 times cos alpha cos beta minus 2 times sin alpha sin beta. So we get 2 is common out. In the bracket we get 1 minus cos alpha cos beta minus sin alpha sin beta. So this is number A. Now we have to find AR square. Coordinate of AR 1 0 and coordinate of R are cos alpha minus beta and sin alpha minus beta. So it becomes 1 minus cos of alpha minus beta whole square plus 0 minus sin of alpha minus beta whole square. That gives again A square plus B square minus 2AB plus sin square alpha minus beta. So from here, if we see, we have cos square plus sin square, then 1 plus 1 minus 2 cos alpha minus beta. So from here we get 2 is common, 1 minus cos alpha minus beta. So this is number B. Then using A, B and star equation, we will get 2 times of 1 minus cos alpha cos beta minus sin alpha sin beta is equal to 2 times 1 minus cos alpha minus beta. So from here we get that is 1 minus cos alpha cos beta minus sin alpha sin beta. 1 is cancelled out and we get 1 minus cos of alpha minus beta. Now 1 is also cancelled out and we will get 2 cos alpha. Sorry, 2 is not here. 2 is already cancelled out. Cos alpha cos beta plus sin alpha sin beta is equal to cos of alpha minus beta. Therefore, for the case alpha greater than beta, we have cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Now we will prove the result for alpha is equal to beta and alpha less than beta. Now we are going to discuss the case 2, that is if alpha is equal to beta, then on the left hand side, that is cos of alpha minus beta, it becomes cos of alpha minus alpha, that is cos of 0 and cos of 0 is 1, and on the right hand side we have cos alpha into cos beta plus sin alpha into sin beta, that is cos alpha into cos alpha plus sin alpha into sin alpha. That gives cos square alpha plus sin square alpha, that is 1, as right hand side is equal to left hand side for alpha is equal to beta. Therefore, for alpha is equal to beta, cos of alpha minus beta is equal to cos alpha into cos beta plus sin alpha into sin beta. Now we have to discuss the case 3rd, that is if alpha is less than beta, that is we have alpha minus beta is equal to minus of beta minus alpha. So as we have cos of alpha minus beta, it becomes cos of minus of beta minus alpha, that is cos of beta minus alpha, because cos of minus theta is equal to cos theta. That is a property of trigonometric cos function. So as in the case 1, if this angle, first angle is greater than second angle, then result is Q. Therefore it becomes cos beta cos alpha plus sin alpha sin beta. that is for beta less than alpha, that is beta greater than alpha, we have cos of alpha minus beta is also equal to cos alpha cos beta plus sin alpha sin beta. So we have discussed the three cases when alpha and beta belongs to 0 to pi. So in all cases we get cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Now we will discuss the case, that is case 2. What happens when alpha and beta belongs to real number? So for given alpha and beta belongs to real number, we can find alpha beta belongs to 0 to 2 pi such that alpha is equal to 2n pi plus alpha 1 and beta is equal to 2m pi plus beta 1 for every m comma n belongs to z. Now then alpha minus beta is equal to 2n pi plus alpha 1 minus 2m pi minus beta 1, that gives 2 times n minus m pi plus alpha 1 minus beta 1, where as m and n are integers, therefore it becomes n minus m belongs to also z. And we know that sine and cos are periodic function of 2 pi. Therefore, cos of 2n pi plus alpha 1 is equal to cos alpha 1, that is cos of alpha, and sine of alpha, that is sine of beta, is equal to sine of, what is the value of beta, that is 2m pi plus beta 1. So it is a periodic function of 2 pi, so it becomes sine beta 1. So cos alpha is equal to cos alpha 1 and sine beta is equal to sine beta 1. Now we have cos of alpha minus beta, that is cos of 2k pi plus alpha 1 minus beta 1, as we name k is equal to n minus m. So it becomes cos of 2k pi plus alpha 1 plus beta 1. So it again becomes 2 pi plus theta. So it becomes cos of alpha 1 minus beta 1. So open this, as alpha 1 and beta 1 belongs to 0 to 2 pi. So this cos alpha 1 cos beta 1 plus sin alpha 1 sin beta 1. So that is cos alpha 1 is equal to cos alpha, cos beta 1 is equal to cos beta, and sin alpha 1 is equal to sin alpha, and sin beta 1 is equal to sin beta, as we proved above. Cos alpha is equal to cos alpha 1. Similarly, we can prove that cos of beta is equal to cos beta 1. So these result can be used by applying the similar rule to the above result. So we get this is equal to cos of alpha minus beta as proved in the first part. So from case 1, and case 2, we get cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. This is the first additional formula for cos. Now we have to do second part of the theorem, that is cos of alpha plus beta. That can be written as cos of alpha minus beta. So it is a form of cos alpha minus beta. It becomes cos alpha into cos beta, that is minus beta here, plus sin alpha into sin of minus beta. And as we know that cos of minus theta is equal to cos theta. Therefore cos alpha as it is, cos of minus beta is cos beta, sin alpha as it is, sin of minus beta is minus sin beta, as sin of minus theta is equal to minus sin theta. So it becomes cos alpha cos beta minus sin alpha sin beta. So we get two formulas of cos, that is cos alpha minus beta and cos of alpha plus beta, that is cos alpha into cos beta plus sin alpha into sin beta. So this is the second addition formula for cos function.